In this video, I'm going to uncover some LangChain pitfalls and opportunities by building a fashion e-commerce chatbot from scratch using generic building blocks. To get some perspective, I'm first going to give you a brief introduction to the new trend of headless e-commerce and highlight what I believe will be a big opportunity for AI in this space. Then I'm going to dive right into writing the code for the chatbot that allows you to Q&A 44,000 fashion products using dense image embeddings. I'm going to use generic building blocks, and this allows us to understand some of the challenges surrounding retrieval, and it only takes a few minutes to build. Finally, I'm going to give you a short overview of some of the different ways you might need to customize your conversational agents in order to make your large language model application enterprise ready. But first, let's have a look at how large language models can benefit the world of e-commerce. One of the biggest trends in e-commerce right now is so-called headless e-commerce, and Shopify is leading the way when it comes to fueling this trend. Headless e-commerce separates the front-end user experience from the back-end e-commerce functionality. This allows for greater customization and flexibility in the design of the user interface. This architecture enables businesses to deliver content across multiple platforms and channels while managing all e-commerce operations from a single back-end system. In the Shopify case, headless e-commerce solutions are built with Hydrogen, a React-based toolkit that helps developers fast-track tailored e-commerce solutions using a modern tech stack. The flexibility that this tech stack provides opens up for using AI and large language models in particular to design the shopping experience. For instance, using LangChain.js in combination with Hydrogen, developers can remove the boundaries between what is considered a chatbot and what is considered a traditional storefront. The headless architecture provides full flexibility in shaping the product retrieval and ranking mechanisms, allowing businesses to fine-tune models that can improve conversion rates. And finally, headless e-commerce makes it easier to contextualize the customer experience using relevant customer data and implement end-to-end personalization pipelines. And all of this can, of course, be aided by large language models and frameworks like LangChain. So let's now have a look at some of the challenges we might face when building a chatbot. I'm going to set up a simple load QA chain with fashion product data from Hugging Face using the vector similarity search that is built into the Sentence Transformers library. Let's get started. The first thing I'm going to do is I'm going to load the dataset that we used in the last video, which is the fashion dataset that's available on Hugging Face. Then I'm going to import Sentence Transformer and util from the Sentence Transformers library. Product images and the metadata about the product images is separated, and the metadata is loaded into a pandas data frame. And then we turn the product metadata into a dictionary. And we can view the individual product images in the notebook. And let's just check the size of the data frame. We have 44,072 products. Then I'm going to instantiate the model I'm going to be using to create the embeddings, which is the OpenAI clip model that maps text embeddings and image embeddings into the same vector space. And then I'm going to be using that to create lists of image embeddings and text embeddings using the product display name and the product images. And once we have the embeddings, we can do a semantic search. Here I'm going to search for blue jeans using the image embeddings and fetching the top 5 results. Alright, so far this is similar to what we did in the last video. Now we want to feed this data to a large language model. And to do that, I'm going to create 2 functions. One function that will do the semantic search and return the results. And one function that fetches the images so that we can look at the images and compare it to what the language model is mentioning. So now I can fetch blue jeans using the getResults function and then use those results to print the images of blue jeans. Now to feed the results to a LangChain chain, I'm going to use a helper function that transforms the results into LangChain documents. Then I'm going to load the OpenAI API key from the environment file, import chat OpenAI, I'm going to import load QA chain and prompt template. And the template I'm using is just a simple standard template telling the language model that it's a shopping assistant that wants to convert customers based on information given. With this in place, we can instantiate the chain, and then we can feed the documents to the chain to get the language model's response. And here we have GPT-4's response to the query looking for blue jeans when it's fed the top 5 documents that comes out of the semantic search. And of course, we can also fetch the images corresponding to the documents that are fed to GPT-4. So far, everything looks great, and it looks like we're actually close to something that could be useful for managing customer interactions. But let's take a step back and think about what it is we want to achieve. So first of all, we want to be able to match images with products from the conversation with the language model. Then we might want to fetch additional product data from an external API, data that's not available in the vector store, and sync that to the language model. And we want the language model to be able to dig deeper into product details if that is what is requested by the customer. So this is need to have. We also want the language model to be able to suggest products based on the preferences of the customer. And this could be based on the browsing history of the customer. If the customer is logged in and identified, we also want the language model to be able to fetch previous purchases. And all of these requirements are pretty basic if you look at this from a customer perspective. But we're actually quite far from being able to do this. And let me show you something with our current example. So here in the notebook, I've changed the main query to looking for blue shirt. And I've made sure that the query is fed to the language model as a question as well. And then I've changed the number of items I'm retrieving in the semantic search from 5 to 10. Now, if we have a look at the output of the chain, the language model is mentioning 5 products, even though I fed it 10 documents. And if we print the images, then we of course get the 10 blue shirts. So there's now an inconsistency between what the language model is mentioning to the customer and the images we're showing. And you can try to change the query to a green shirt instead. And you can see that the language model is now only mentioning 1 green shirt, even though we have 10 green shirts. So what we really want to do is we want to know what the language model is going to be mentioning, and then we want to show the images corresponding to that. And that requires us to get structured output out of the language model, which is surprisingly hard. This is just one of many things that you need to be thinking about if you want to implement this for a real business. Let's have a look at some of the other potential pitfalls or opportunities for optimization. In the example I just gave you in the notebook, we used image embeddings to do the vector similarity search. You want to extend this to hybrid vector similarity search, including both text and images. And you want to look into using both sparse embeddings representing the text syntax, as well as dense embeddings representing the semantic meaning. Optimizing precision and recall will be very important for the performance of the chatbot. Recall measures the completeness of the search results, whereas precision measures the density of the relevant items. And once you have retrieved the search results, how do you rank or sort the items in order to optimize conversion rates? Another important consideration is how do we store the vector data. In Redis, for instance, we can store the vector data either in a hash or an JSON object. The right format depends on the use case and what strategies you want to use to optimize the memory in the database. Getting structured output out of the language model is an important challenge to solve. Otherwise, you'll have to put unnecessary restrictions on the model, and you want to allow the AI to do what it needs to do. And finally, how do you provide needed customer information to the language model at runtime so that it'll be able to serve the customer in the right context? Again, this is non-trivial because of security and data privacy concerns. So a lot of this data will need to be transferred server-side. So to summarize, yes, you can build a chatbot in 5 minutes, but you can't build a good chatbot in 5 minutes. Building a good conversational agent is really hard. There's a lot of uncertainty and fear surrounding AI right now, but I think this demonstrates that there are plenty of interesting problems to work on, especially if you're a tech person. And as always, when technology takes a leap, new skills are required. I hope you found this video useful. If it was, like and subscribe. Thanks for watching.